a very robust and interoperable ecosystem. No one organization could have created something like this. Okay, so here we are. We have this 3D globe engine on the web. We can put 3D models into it. But the data acquisition trends really started to show us that we needed a lot more than terrain and satellite imagery. There were LiDAR collecting these massive point clouds. There was open data from a lot of city governments providing 3D buildings. There were drones taking photos, and then the photogrammetry algorithms were producing these massive models. And people kept coming to us saying, hey, we want to put this in context on this Cesium globe. And all these things, they sound very different, right? But it turns out that they have a lot in common if you want to try to stream and view them in the Cesium globe. And you can use a similar technique for all of them called HLOD, hierarchical level of detail. So we built something that we called 3D tiles, which was an open specification to define how to do this hierarchical level of detail, how to take these massive photogrammetry models, these massive point clouds, and stream them in that geospatial context. We put it out there as open on GitHub. We spoke about it on our blog. And then a group came to us called OGC, the Open Geospatial Consortium. And Scott Simmons there said, hey, Patrick, we think you're onto something there, and we'd like you to bring it to the open standards community to encourage adoption and to build awareness. And we have this community standard process. And we said, well, wow, that sounds like a great idea. And these here, by the way, these are original images that we showed that the first time that we presented this to OGC. The top one's from Virtual City Systems. The bottom one is from Vricon, now part of Maxar.